Welcome! Today, we're going to tackle a common type of equation involving absolute values. Our goal is to find all real solutions to the equation, the absolute value of x squared minus 4 equals x. By the end of this video, you will be able to solve absolute value equations like this one, understanding all the steps needed to find the correct solutions. Before we dive into solving the equation, let's take a quick moment to recall what the absolute value function actually does. The absolute value of a number, denoted by these vertical bars, is its distance from 0 on the number line. Because distance is always positive, the output of the absolute value function is always non-negative. This means that if we are given an equation that says the absolute value of something equals something else, say the absolute value of A equals B, the value of B on the right side must be greater than or equal to 0. Let's repeat that. The expression outside the absolute value must always be non-negative. This is a critical property that acts as a first check on our potential solutions. In our equation, the right side is x. So, for any solution to be valid, x must be greater than or equal to 0. If we find a solution where x is negative, we'll know to discard it. It's an extraneous solution. Now, let's explore the fundamental way to get rid of the absolute value bars. There are two main cases to consider. Case 1. The quantity inside the bars is non-negative. If a is greater than or equal to 0, then the absolute value of a is simply a. For example, the absolute value of 5 is 5. So the equation absolute value of a equals b becomes a equals b. Case 2. The quantity inside the bars is negative. If a is less than 0, then the absolute value of a is negative a. For example, the absolute value of negative 5 is negative 5, which equals positive 5. So the equation, absolute value of a equals b, becomes a equals negative b. This gives us the general rule. If the absolute value of a equals b, then either a equals b or a equals negative b. Applying this to our equation, the quantity inside the bars is x squared minus 4. The quantity outside is x. This means we can split our single absolute value equation into two separate, standard quadratic equations, x squared minus 4 equals x, or x squared minus 4 equals negative x. Let's solve the first case. Our objective here is to find the solutions to the first quadratic equation. The equation is x squared minus 4 equals x. To solve any quadratic equation, our first step should always be to set it equal to 0. We can subtract x from both sides to get x squared minus x minus 4 equals 0. This quadratic equation is now in the standard form, ax squared plus bx plus c equals 0. Notice that this one is not easy to factor. In such cases, we turn to the quadratic formula. Remember, the formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. For our equation, a is 1, b is negative 1, and c is negative 4. Let's substitute these values into the formula. Plugging in the values, we get x equals negative 1. Plus or minus the square root of negative 1 squared, minus 4, times 1 times negative 4, all over 2 times 1. Now, we simplify the expression inside the square root, which is called the discriminant. Negative 1 squared is 1, and 4 times negative 4 is negative 16. So we have 1 minus negative 16, which is 1 plus 16, or 17. This gives us our two potential solutions from case 1, x equals 1 plus or minus the square root of 17, all over 2. Now let's tackle the second case. Our objective is to solve the second quadratic equation. The equation for case 2 is x squared minus 4 equals negative x. Again, we want to set this equation to 0. Let's add x to both sides. This gives us x squared plus x minus 4 equals 0. This quadratic equation is very similar to the one in case 1, but this time our b value is positive. Here, a is 1, b is 1, and c is negative 4. We can use the quadratic formula again. Substituting these values, we get x equals negative 1 plus or minus the square root of 1 squared minus 4 times 1 times negative 4 all over 2 times 1. Let's simplify this expression. Inside the square root, we have 1 minus negative 16, which is 17. This gives us our two potential solutions from case 2. X equals negative 1 plus or minus the square root of 17 all over 2. Okay, we've done the algebra and found 4 possible candidates for our solution. The objective here is to determine which of these are real solutions to our original equation. Our four candidates are 1 plus the square root of 17 over 2, 1 minus the square root of 17 over 2, negative 1 plus the square root of 17 over 2, and negative 1 minus the square root of 17 over 2. We must verify each of these against our initial condition. Remember that for the equation vertical bar A vertical bar equal sign B to be valid, B must be non-negative. In our case, the right side was x, so we must have x is greater than or equal to 0. Let's check each candidate. We'll use the approximation that the square root of 17 is about 4.12. First, let's look at 1 minus the square root of 17 all over 2. This is approximately negative 1.56. Since this value is negative, we must reject it. It is an extraneous solution. Next, let's consider negative 1 minus the square root of 17 all over 2. This value is also negative, so we must reject it as well. Now, let's check 1 plus the square root of 17 all over 2. This is about 2.56, which is positive, so this is a valid solution. And finally, let's check negative 1 plus the square root of 17 all over 2. This is about 1.56, which is also positive. This is also a valid solution. So, after our verification step, we are left with two real solutions. X equals 1 plus the square root of 17 all over 2, and x equals negative 1 plus the square root of 17 all over 2. These are the two values that satisfy both the equation and the non-negative right-hand side condition. Let's quickly recap what we've learned and the steps we took to solve this problem. First, when solving an absolute value equation like absolute value of a equals b, always start by checking that the expression b on the right side is greater than or equal to 0. If it isn't, there are no real solutions. Second, split the equation into two separate equations, a equals b and a equals negative b. Third, solve each of these equations independently to find all the candidate solutions. Fourth, and most importantly, plug each candidate solution back into the original equation to verify that it is a valid solution. Remember that solutions must be consistent with the condition b is greater than or equal to 0. Today, you've learned how to solve absolute value equations that lead to quadratics, and how to identify and reject extraneous solutions using the non-negativity property of the absolute value. I encourage you to try similar problems and pay close attention to that crucial verification step. Thanks for watching.